Hi there, I'm How. This is just another video of me solving random code problem. So no, today we need to find all the possible permutation. So in other words, like how many ways can we arrange 1, 2, and 3, right? We have like three number. We have 1, 2, 3, right? 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, and 3, 2, 1, right? Which is 6. So this is like 3 factorial, right? So how many ways can we arrange a set of numbers? So every time we find a permutation, we need to copy them, right? Make a copy of them. So that is like n, right? So the time complexity would be n multiplied by the n factorial, right? And we can look at an example here. So 1, 2, 3, right? So we can pick one, right? If we pick one, then the only option left is 2 and 3, right? So we can either pick 2 or 3, right? If we pick 2, um, then our only option left is 3. If we pick 3, the only number we have left is 2, right? So similarly here, like each number have a chance of becoming a root, right? So the 2 here, if we pick 2, then the only option left is 1 and 3, right? If we pick 3, the only option left is 1 and 2, right? 2, 1, the last one will be 3, right? If we pick 3, we only have 1 as the last option, right? 3, 1, 2, and then 3, 2, 1, right? So this would be our tree, right? You can visualize this via a tree. So we can use backtracking for this, right? We can pick one or like not pick one. We can pick either one, right? Or two or three, right? We can pick each of them as the root, right? And as we iterate, we're just gonna add more numbers. That we're gonna add the numbers that we're gonna add the number that is not in the current array yet, right? So you can think about it like this. It will be our array, right? 1 and 2. This 1 and 3, right? This is 1, 2 and 3, right? It is 1, 3 and 2, right? So on and so forth. So we're gonna iterate over like the original input numbers, right? 1, 2, and 3, and we're gonna add the number that we haven't. We're gonna add the number that hasn't been included in the current permutation, right? And we're just gonna try it with every possible uh, combination. Okay, so let's code this up. So we're gonna have our result, and we can return the result at the end. And we can do factor as our helper function here. We can start with the uh, an empty array, right? Because backtrack. Let me move this down. Equal to array. Right? So if the what is our array case? So when the array dot length, right, is equal to the num dot length, which means we found permutation, they want to return, right? And then add it to our result. Push array dot slash because we want to make a copy, right? Because we need is backtracking, so we want to try. We want to mutate the array later, right? Right. So for example, we can try 1, 1, 2, right? And then 1, 2, 3. Right? When we return backup, we can pop off the 3 here, right? Which is 1, 2, and try with like a different number if we have one. right? Let's look at this example. Okay, so uh 1 2, right? As we return back up, we can pop off the 2. So when we iterate down, we add the 2, right? So now when we return back up, we can pop off the 2 and try with the next number, right? 1 and 3, right? If you have 1 2 3 4, you're gonna try with 1 2, right? You delete the 2 here, you try with 1 3, and then 1 4, right? Until you ran out of the numbers. So because we are mutating our array, we want to make a copy. We don't want to add the whole array in. Okay. So we need to iterate through each input number, right? And try with every possible combination. So if the array that includes num but not include nums, right? And we want to try this number, we want to call array dot push, right? And array dot pop. We want to push the current number, and we want to go the backtrack, passing in the array, right? So we're gonna try one two, right? 1 2 3. When we return back up, we're gonna pop up the 3 and then pop off the 1, right? And we're gonna try with the next number in the series, which is 3. Right? So I think that's pretty much it. Let's give it a try. Accept it, right? And it worked. So we can also solve this using the iterative approach. So it is our uh, backtracking, right? Recursive backtracking approach, right? But we can also like solve this using the iterative approach. So how can we do that? So let's take a look here. So we can have an array, an empty array. We can start out with the double array, double empty array, the 2D array, right? So we're gonna iterate over the input number as well, right? And every time we iterate over the input number, we're just gonna add the number we are looking at here, right, to every possible index of the current result array, right? So if it is set length 1, so iterate with 1 time. So we're gonna add 1 to this, so 1, right? So we look at 2 now, right? So right, so we're gonna add 2 to every possible index, right? We're gonna add 2 1, and then 1 2, right? So we will iterate from index 0 up to, we're gonna look at the current length of the result array, right? We'll look at the current length of the result array, and then iterate through it from the index 0 up until the length, up and until and including the length, right? So 3 here, similarly, we can add the 3. So for each subarray, we want to add the new number, right, into every single index. So if you look at this subarray, we're gonna add 3 2 1, right? And then 2 3 1, and then 2 1 and 3, right? And now we look at this array and we do the same thing, right? So 3 1 2, right? 1 3 2, and then 1 2 3, and we can return this, right? So if you look at the result array, this is the result array, right? So the result array didn't append more number here. So if we got into this step, right, we don't see like this array anymore, right? So the result array evolve over time. So we use the current state of the results array to build out the next permutation, right? But then we want to reset the results array to be the new result here, right? Let's say this would be our new array, right? So after we build out the next permutation with the next number, we will set the result array equal to the new array. Okay, so let's try that. So let me comment this out for now. Right, we're gonna have our results array. Of course, we want to return it again. Right, and iterate over each number, so nums of for each num. And we want to iterate over each subarray, right? So the result here should be double array. So result for each subarray, right? And we want to make a new array, right? And then we want to set the result equal to the new array, right? Before we move on to the next number here. Right. So this for loop is just reiterating over each number. The new array here, right? It's just for us to build out the next permutation with to build out the permutation with the next number, right? And then we will set the result array equal to the new array uh after we finish. Because as you see here, the one here it doesn't get moving to here, right? We just keep building out the new results array. Okay. So that is that. So that, what do we want to do now? So for each subarray, right? For each subarray, let's say 2 and 1, right? 2 and 1, index 0 to 1, right? We want to insert the new number that we are looking at into every single position, right? So index 0, index 1, and index 2. So we want to iterate from 0 up to the length, right? Which is length 2 here. Okay, so let's try that. So we need to make a copy of the subarray because we want to reuse it for every number. Subarray equal to so let's say copy equal to subarray dot slot, right? We can do copy dot splice at index. Yes, and we need to iterate over from 0 equal to subarray dot length, right? And this go inside. Okay, so we need to make a copy of the subarray, and then we need to split it from index. At index I, we remove 0 element, and we're gonna add the current number, right? And we will add it to our results array. Oh, sorry, new array. Push, copy, right? So the inner for loop here is to iterate over every index of the subarray, including the length, right? And then inject the number we are currently looking at into every single position of the subarray. And then we push that into our new array as the next permutation. And then at the next level, we will reset the result array equal to the new array. Oh yeah, this should be left. Right? Let's try it again. Accept it. And then let me clear the board here. Okay, so submit, and it worked. Thank you for watching.